Hello, everyone. Among the subscribers of the Global Energy Association Global Energy Prize, this is our 10th consecutive meeting with our gurus, that is the authors of the forthcoming books and 10 breakthrough ideas for the next 10 years in energy, but also now, finally, people from the shortlist of this year's prize. With me, I have Sophia Morgan from the Global Energy Association, and we're talking to Dr. Yablonovitch in the United States, California. Hello, sir.
Good morning. Nice to see you.
Okay, we're being watched by people who are deeply involved in what we're talking about, but also by the people who want to learn things. So let me give them a quote and maybe, possibly, kill them off immediately by saying that Eli Yablonovitch invented and developed several new concepts revolutionizing the view of electromagnetic radiation interacting and being manipulated by solids. With respect to commercial utilization, this led to photophonic bandgap materials and filters. Well, for those of you who've survived the last 20 minutes, here's the first question to Dr. Yablonovitch. What are we talking about here?
It's that particular idea is a form of structure that resembles a semiconductor, but instead of having electron waves, it has electromagnetic waves, typically light waves instead of electron waves. So I hope that helps.
It certainly does, but also people may be a bit confused because we're talking to someone who's been nominated for the Global Energy Prize. But the first thing which comes up when you Google you are things related to mobile phones. What's the relationship?
Well, there actually is no relationship. In my field, we try to do many different things simultaneously, and I have my name is associated with solar panels, something called the Yablonovitch limit, but it's also associated with two inventions that make the internet possible. I've contributed to telecommunications, and I am the founder of a company that sold 2 billion cell phone antennas. It's with a B, that's 2 raised 2 times 10 to the 9. So it's about 1/3 of humanity is using the cell phone antenna, which I developed.
Coming back to the mobile phones, cell phones as you call them in the United States. We're talking now on the internet. Which of your ideas is working now that we're speaking?
Okay, now that we're speaking, I invented a new way of making the semiconductor laser that makes this phone call possible. And I introduced the idea of straining, that is to say, squeezing the semiconductor laser. And it was at a time when I presented that, everyone said, if you squeeze it, you'll ruin it. It'll lose all reliability. And it turned out, of course, it was far more reliable. And it's better, and it's used for all internet communication and all phone calls. The other thing I invented, and this one did have a photonic crystal in it, was a communications method called silicon photonics, where the chip, which is normally just used for electrons and electricity, that the same silicon chip could be used for photons. And that is in every data center. So if you check your email, or if you have a Zoom call as we're having right now, what you find is that the signal goes through a data center. It uses the chips developed by my company. That company was called Luxtera, and the signal continues on to across the oceans and goes all the way to Moscow and back.
So when the picture becomes scrambled, we should blame whoever else other than you.
That's right. Please do not blame me.
Coming back to energy, I know that Sophia has got a particular question for you.
Yes, you have already mentioned Yablonovitch limit, but you also gave the world the whole plate of scientific terms like Yablonovitch limit, which is the light trapping factor, and Yablonovite, the first photonic crystal you have invented. So it seems like revolutionizing the optical communication is not enough for you. What other projects you are up into now?
Well, by the way, congratulations on doing a great job reading up on me. It's clear that you have quite a bit of scientific knowledge and understanding. Right now, I'm working on something new and controversial, and that is a new way of computing. that doesn't follow the normal pattern for computing, and instead it uses optimization. It's a new way of using physics to do optimization. Now, to give you an idea of how important is optimization, it's central to artificial intelligence. So with computing, the old computing is gradually becoming smaller, and the new computing is artificial intelligence. So if you have a supercomputer today, it would be about half of what an old computer is, but half of it will be artificial intelligence. And physics provides a way of doing the optimizations that are needed for artificial intelligence. So it's exciting. It keeps me busy.
It's fascinating, sir. What about the energy factor? Where does it fit?
Well, the energy is very important because computing has now reached the limits of energy. You know, in data centers, we are using so many megawatts. It is the most important thing today in computing is trying to conserve energy. But energy is an industry of its own, as you well know, and the solar panels are part of it. One of the things that I've been telling people is that someday we will use the solar panels to produce liquid fuel like oil. And we'll have a great integration in the energy industry. I think at some point, the solar panels will not be the enemy of petroleum, but that they will work together.
Tell us more about it.
Well, just to give you an example, we can use the solar panels. We have, today we have an excess of solar panels. We have, in some places like California, there is too much electricity in the middle of the day. We can use that excess electricity to produce hydrogen, and from the hydrogen, you can use it to create methane and to create other forms of fuel. And the main point is that to go further in solar energy, we need storage. We need to have a way to store the energy, and liquid fuels are a way to store the energy.
Let me ask you a very Russian question then.
Yeah.
Hydrogen, it's one of the most fashionable words in today's energy sector. However, there are several modes, several recipes, how you can produce it. The traditional way, the old-fashioned traditional way, is coal. Then there's natural gas. Then there are all those new fascinating and new technologies. Which one would you prefer?
Well, what I was referring to was not one of the ones that you listed, but rather the idea that the excess electricity that comes from solar cells in the middle of the day, that excess electricity can be used to create hydrogen and perhaps to store it underground. So we have, the solar cells are in some ways very limited because we don't have a means of storage. All the other forms of energy, there's an easy way to store it. But with solar panels, we produce so much electricity in the middle of the day, it's essentially free. And that's already the situation in California.
Absolutely, I get what you say, but let me then catch you with one little controversy, contradiction. You said that there will be a stage when the solar panels are not going to be enemies of oil and gas. But then when we talked about hydrogen in particular, you said that no, you refer to the modern methods, which are about using electricity to produce hydrogen, not from oil and not from gas and not from coal. So what do you have in mind?
Well, what I have in mind is that once we have the hydrogen, it's relatively easy to upgrade other forms of carbon, to upgrade them into hydrocarbons. So what I'm predicting is that you will see that the product of the solar panels will actually be used to make liquid fuels being petroleum products.
Good, well, understood now.
I did. Like you said, I really did read a lot about you, and I know that when you was 10 years old, you decided that you will become a scientist. And the thing that influenced that was the launch into space Sputnik 1. Is it true?
That's absolutely true. the launch of Sputnik 1 was extremely influential. And I remember as a child that my parents were talking about it with the greatest respect. And so that influenced me to think that this was important, because my parents were obviously very overawed by Sputnik.
This is nice to hear. Well, sir, we're going back to the beginning of our conversation. I should introduce you once again to our subscribers as one of the scientists all over the world who've been shortlisted for the Global Energy Prize this year. The International Award Committee is going to decide your fate, if you so wish, on 7th and 8th of September, choosing 2 or 3 laureates, winners out of the 15. But I already congratulate you on becoming a distinguished member of that shortlist. However, we've done our reading, Sophia and I, well, she's been guiding me, of course, and we've found out that you have been awarded the Benjamin Franklin Medal, the Edison Medal, the Newton Medal, the Buckley Prize. Why do you need the Global Energy Prize then?
Well, I think that's up to you. Certainly, I'm very proud of my awards, but I think of it a little differently. I think of each award, and it was for something specific, and some specific recognition for something that I did. And so that certainly makes me feel good, and I will certainly be very honored with the Global Energy Prize if I happen to be selected.
Lovely. Well, thank you so much indeed, sir, and best of luck in September.